Hi there, welcome to a presentation of solving systems of linear equations using the inverse of the matrix of coefficients. My name is Charles Suasfanim.
Right, so let's just go over what we've seen again. This is the system of equations. What we want to do, we want to transform it to this kind of situation whereby A is the matrix of coefficients, X is the matrix of the unknowns column vector, and the B the column vector consisting of the element entries on the right hand side there. And then we take this situation, we take it back to where we solve the simple equations like this. So now what we want to take what we do here and try to see whether we can do it with matrices. So how do you do this? How to solve this equation? Remember, to solve for x here is to change the coefficient here to be 1, but not just changing, transforming the equation equivalent. So then what we do? We would normally multiply here by 2 to the power minus 1, and this is 2 to the power 1, and there multiply by both sides by 2 to the power minus 1. Remember, 2 to the power minus 1 is the same as dividing by 2 both sides. I'm writing in this notation because I want to talk about something like this in the case of matrices. So once you've done that, it is clear that here 2 to the power minus 1 times 2 to the power 1, they give us an identity for multiplication for which this is true. So now we know already that if we multiply matrix by its inverse, we get an identity, so which also is going to be true that the I times the x, the identity matrix, will be equal to x times the identity, and that will give us what? X. So then that's that. Then you notice that x here is a column vector like this, and now if you multiply here, because these two can multiply it because the type is 3 by 3, 3 by 1, these two numbers here are equal, meaning we can multiply. But once we can multiply there, it means that this 3 and this 1 is going to give us the type of the answer, which is going to be exactly this one: 3 rows, 1 column. Then saying these two are equal is saying x is equal to b1 and y is equal to b2 and z is equal to b3. Just b1, b2, I'm just saying 3 different numbers. Just chose the I, b there for coding them. So now let's do this first step, this one. Now let's transform our equation to this. If you check what we're doing here, we'll be actually undoing what we call multiplication of matrices here, because we've got a matrix here which is x, y, z, which is multiplying another matrix. So let's do this way: x, y, z. If we say x, we remove x, y, z, and doing this multiplication, we must see what is left there. We must be able to see what is left. I don't know who wants to tell me something. Let's say I write 1 there. Is it correct? Then 3, then there 4. So I think you seeing this, you must see that these plus signs here are just a result of multiplying these two matrices. Then you come here, you collapse all these all these equal signs, you collapse them into one equal sign like we have here. Then we got another right side matrix here. This is going to be minus 3, minus 5, and 6, and then you've got that. And then the equation is exactly like that. I hope everybody understands that. Okay. So now what do we need to do now? If we call this matrix A, if we want this kind of a thing to happen, that we multiply here, we get x, then we need to have the matrix that. But for that, I think you remember, a matrix is an inverse when the determinants are not equal to 0. So the first thing we must do maybe is to try to complete the determinant. Are we fine? Okay, let's try our A explicit there, A as. So in this case, solving this system of equation, it mostly depends on working with A. Why simply, so I request you to work with A throughout and just end up with that simple multiplication again. Then please check that the matrix is copied correctly. Is it fine? So now let's calculate the inverse. Again, let's use the cofactors and minus for the inverse. We're going to say determinant of A. Which row do you want to choose? And remember, we can move you along a row or along a column. Doesn't matter. Which row do you want to choose? Come on. Row 1. Want to move along row 1? Yeah. Okay, let's do this. Then we're going to have 1 here, brackets minus 1, power 1 plus 1, the minor determinant, which is 2, 1 minus 1, and 4. Please, guys, agree, check that's correct. It's fine. Then plus, I'll say 3 there. 3 is the entry, 1. This 1 is that entry. So this 3 is this entry. So minus 1, 2, no 1, always row plus column number, then that. If those who are not following what we're doing here, if we're taking 1 plus 2 here, we're going to drop row 1 and we're going to drop column 2. So we're left with 2 and 1. So right here 2 and 1, and then minus 2, 4, minus 2 and 4. This part is mechanical, but you must know how to do the mechanics. Are we together? Okay, then the next thing is going to be plus another 3, brackets minus 1, 1 plus 3. Then we are left with 2. Remember, dropping out the first row and the last column, we're left with this entries here: 2, 2, negative 2, negative 1. Then you've got that. Then we've got now a hint which I must give you in case you're writing a test or exam, whatever the case might be. If you are using this method to calculate the determinant and there is a row or a column which has got most zeros, the best thing is to use that one. Move along a row which has got most zeros, or along a row which has got along a column which has got most zeros, or along a row which has got most zeros. Altogether, what you do, if there's a 0 here and a 0 here, there's only this determinant to calculate. If there's 1 0 anywhere there are only 2 things to calculate. So it economizes your way, economizes your I mean, in terms of time, you move fast. I think that's clear. Okay, let's do the multiplication now. The sign is going to be positive, so we're going to have a 1, but 1 times this determinant is only going to be this determinant. So it's a 4 plus, it's an 8 plus 1, which is a 10. Oh, 9. Oh, I thought it was a 10, man. 8 plus 1 is not 10. 9. Okay. Then here, the sign is negative, isn't it? Okay, we've got a minus 3 there. What do we get here? 8, 10. Times that 3, minus 3 actually, minus 30. So we've got minus 30 there. Then coming this side, it's a positive sign, so we've got a 3 there. What do we have here? Got a minus 2 plus a 4, which is a 2, multiplied by 3. That is a 6, positive 6 plus 6. So this gives us 15, and that is that, then which means the negative 15, and this is not equal to 0. Therefore, A inverse exists. Are we together? Yeah. So now we're sure that what we're looking for is. Now let's go on to get what exactly we're looking for. This is what we're going to do. Then we do this. Check what we're going to do here. First of all, I'm going to calculate what I call A11. This A11 is nothing other than this. It's just the determinant of 2, 1, minus 1, and 4. That's all. Without these two perfect, this perfect. Are we together? So that's a minor. We call that a minor. So that is going to give us what? 8 plus what? 8 plus 1. 8 plus 1. 9. Okay. Then I'm going to have now A12. We call this guy minor. That we're going to come here and do this. 2, 1, minus 2, 4. That. What is that? 8, 10. Okay. Then there's A13. Then this is 2, 2. Minus 2 minus 1, that. Then that. Now guys, this, I think at this moment you don't need to understand what we're doing here, but you need to see how you do it, and what you must know is how to calculate the determinant, and you must see exactly how to get to A11. It's just a question of knowing how to do it. Then you will see that how to use this thing to get something which you're going to use wisely. Okay, so what is this now? This is going to minus 2 plus 4, that is 2. Okay. So then what we're going to follow, I'm going to follow with A21. I'm just following the rows. So what I do here, I drop the second row and the first column. So if this second row is not there and the first column is not there, what are we left with? 3, 3. 1, 4. That is what I'm saying. You must know. You must see how I get that. And then you must know how to calculate the determinant of 2 by 2. So that is 12 plus 3, which gives us what? 15. Then A 2, 2. A22 is going to give us a cross here. Cross. So I left with the corners only. That will be 1, 3, minus 2, 4. Does everybody see what we're doing? I think that's mechanical shit. Do you see the mechanical of what we're doing? A11 is this, A22 is this, A32 is this, A23 is this. So then that will give us what? That will give us a 4 plus a 6, which will give us a 10. And then we've got A 2, 3. Minor there. Zeno, can you tell me what's called? Okay. 2, 2 minus 2 minus 1. Then this gives us what? We calculate this determinant here, we get a minus 2. Oh, sorry, that's not correct. Is that what you gave me? What are you doing there? We're dropping row 2 and the last column. Can you correct it? Good, 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 good. So I think I did a good thing to ask you, Zino. Then you showed me what you don't know and what you're going to, what you've just learned now. So it said 1, 3 minus 2, 1. Please be careful. This can happen not because you don't know, but just you overlook. So which means the picking of numbers, you must be very, very careful. You can just overlook, knowing what you're doing, but overlook one term, you just spoil everything. So what's this? 1. Here. Okay, this will be minus 1 plus 6, which is 5. Okay. Now let's start the last row now. 3, 1. Oh, the matrix is no longer visible, no? Now there is the matrix. There is, we want 3, 1. Yeah. Can you have our sister here giving us the entries? Sorry, can you give us the entries? What you get there? Come again? Come again? The matrix is put it here already. Come again? 3, 3, 2, 1. Correct. 3, 3, 2, 1. And that results in, because what is the result here? It's going to be 9. 3 minus 6 minus 3. Okay, then A 3, 2. Yes, Eddie, can you give us the entries here? Come again? 1, 3, 2, 1. Is that correct, guys? 1, 3, 2, 1. Then this is minus is 1 minus 6 minus 5. Good. Then A 3, 3. What are going to give them? 1, 3. 1, 3, 2, 2. Then that is what? Minus 4. Okay. So these are minus, guys. Right, guys. Let's call all these are minus calculated here. Let's like to call this minus. These are minus. Now, once you've done a minus, what we need to do now, we need to somehow create our cofactors. This is how we create cofactors. They say cofactors. I think I was too fast there. What are the cofactors now? Well, let's call the cofactors C1, 1. C standing for cofactors. That's right. So I'm using C so that it suggests to you those minus are minus for matrix A. Now these are cofactors. Call them cofactors C1, 1. So what do you do? You go there to A11, then you do this. You get minus 1, 1 plus 1 multiplied by A11, 1. But I'm not always going to write this. I'm going to write this only once here. Then we just say that. So what's going to happen here? What are going to have? You are going to have 9. Now C1, 2. We're going to have minus 1, 1 plus 2. Multiply by that, which is just going to be 10. I'm not going to go to A now. Then this is going to give us what? Minus 10, because there are 3 matrices side. Then C, 1, 3, then minus 1 to the power 4 multiplied by 2. And this gives us 2. Once we have done one row like that, it becomes very, very fast. What do we know? We know that if we've got 3 negative signs, we get odd number of negative signs, we get negative. Even number of negative signs, we get positive. So when we come here now to C, 2, 1, this is 3, which means we have a negative sign coming up here, isn't it? Then we come and multiply with that, we are getting a negative 15. Now I'm doing this thing now faster because people are getting experience, isn't it? So at the end of the day also, you're going to almost do it with your eyes closed. Then this is 4 negative signs, positive. Then you go there and multiply by positive 1. Then this is what? It's negative 10. 10. Yeah. Then here C, 2, 3, 5 negative signs, that will be negative. We come here, multiply by this by negative, we get that as negative 5. Then you come C, 3, 1 equals. We're coming here, this is 4. In this negative sign, positive. Then positive or negative, it becomes negative. Then this is 5 negative signs, and there's a negative there. Then this would be equals to 5. That will be C, 3, 2. Then coming here, C, 3, 3. 6 negative signs, that's positive. We come here, multiply by positive, we remain with our negative 4. Are we together? Okay. So now what we can do now, we can now create our cofactor matrix. So what we do is we get our C for our cofactor. Are we together? Then we do the entries now. Those minus after incorporating the sign vector, then it should be 9 minus 10, 2 minus 15, 10 minus 5. Minus 3, 5 minus 4. Are we together, guys? So now what do we need now? We need the adjoint. The adjoint of A. This is read as. You read this as. Read as adjoint of A. What is that? The adjoint of A is A that is actually coming from C, and we've got to transpose C. Then you get this as transposing row becomes a column. So 9 minus 10, 2. Minus 15, 10, 10, 1. Minus, okay. Then 3 minus 3, 5, negative 4. What hasn't changed there? There's one part of that thing that matrix hasn't changed. What is it? The principal diagonal does not change. Because that's actually the center of rotation. When you're rotating, the center of rotation does not move. Okay. So then, now A inverse is defined as 1 over the determinant of A. Now somebody can explain something here. Why did we have to check that the determinant is not equal to 0? Why did we have to check? Because otherwise if it was 0, this was going to be impossible. Then once this is impossible, the inverse does not exist. Are we together, guys? Okay. So then this will be multiplied by the adjoint of A. Are we there, guys? Then now what do we do? Let's write this now and write 1 over 15 multiplying by this matrix 9 minus 15 minus 1 minus what? Minus the 10, 10, 5, 2 minus 5 minus 4, and we close our bracket there. That is our inverse. Where is it? Minus 3 where? Here. Good, that's minus 3. Okay. Now, this is our inverse. If we really want to check, let's say we want to double check our calculation, we really need to do this A inverse by A, or we do A multiplied by A inverse. If our work is correct, we must get an identity matrix which should be equals to a 3 by 3 identity, which would be 1 0 0 0 1 0 0 0 1. That's that. And I encourage you to check this. I encourage you to check it. Let's check it. Let's check it together so that we show that we get that. So what we're going to do, let's do this one. Let's do this one. So we're going to write our 1 over 15 here. Remember, 1 over 15, if you multiply matrix here, it will just come in here and multiply everything. So what we're going to do, we're going to hold on with that 1 over 15. Let's not multiply by 1 over 15. Let's leave it outside there and copy the matrix as 9 minus 15 minus 3 minus 10 10 5 2 minus 5 minus 4. Please check whether I'm copying it correctly, because there might be a slip of a pen there that can cause a little problem. Is it copied correct? Okay, now we've got our matrix and our inverse together here. So let's do the checking. Let's do this. First of all, we said we're going to say A inverse multiplied by A, which means taking this 1 over 15, 9 minus 15 minus 3 minus 10 10 5 2 minus 5 minus 4, and that. And copying the original matrix A, remember this is inverse of A. Now we copy A as 1 3 3 2 2 1 minus 2 minus 1 and 4. Now we're going to carefully do the multiplication. The determinant is minus 15. Are we sure, guys? Double check determinant. So then we got minus over 1 over minus 15 here. Minus 1 over 15. Is that correct? Did you get minus 15? Sorry?
Yeah.
Okay. Okay. Thank you for the correction. Let's now do our multiplication. Meanwhile, let's forget about this minus 1 over 15 and just leave it there and do the multiplication of matrices, which you can see there. All together. I hope your multiplication is as bad as mine. Then we're going to do this thing maybe slowly or fast, depending whether it's bad or it's good. Let's see. Let's take this column. Remember how to multiply matrices. We take this column, we sort of put it there, we rotate it anti-clockwise, we match there. We're going to have 9. Check what I'm doing there. We're having 9 minus 30 and plus 6. Do you agree with me? And that is minus 15. So this is going to be minus 15. Remember, when we multiply with 8 these two things. Do you remember multiplication of matrices? Are you fine? If you're not fine, please tell me. Do you remember how to multiply matrices? You don't know how to multiply matrices? Okay. So, okay, what do we do here? We take this column we pick it up and put it this way. We match this one with the 3. Then we drop it anti-clockwise. If we take this, match this with 3 and drop it anti-clockwise, this 1 is going to come to 9, 2 is going to come to 15. Do you agree? Then wherever they match the entries, we multiply them. Also going to have a 1 times 9, which is a 9, and a 2 times minus 15, which is minus 30, and a minus 2 times minus 3, which is 6. And all this, the product must be added. All together? Okay. So when you add there, you get minus 15. All together now. Now what we do now? This column now is lying horizontal here, with a 1, a 2, a minus 3. Then we pull it down. It should pull it down until it has gone to every row in the matrix should be multiplied. So which means next time it must come here. All together. So the next thing we're going to have here is what? Is negative 10, positive 20, 10. 10. It will be 2 or times 5. Negative 10. Negative 10. This gives us a 0. And then we're coming here. Remember, we're moving along, down, going down. We are making a column. That's why we're doing that. So I could put a 0. All together, guys? Okay? Then let's come to the last one now. When we pull it down, it comes here. We're going to have a 2, a what? A negative 10, a positive 8. So this is a 10 minus a 10. So this is a 0 again here. All together. At this moment of doing this thing, we must be thinking of what do we expect. What do we expect at the end? We expect something with 1s along the principal diagonal, 0s everywhere. Oh, we've already got 2 zeros at this. So it's promising. Is it promising, my sister? So why are you so sad then? You're not sad? Okay. Right. So we come exactly with this one. We come exactly with this one. That one again will lie horizontally. Sorry for this, for the disorganization there, but I hope everyone can imagine what is happening there. This is lying there horizontally. The 3 will be there, 2 will be there, negative 1 will be there. Then it's going to be pulled down to visit every row. Then you tell me what we matches there. Right. So now we're saying now once this column is lying horizontal like that, it will be pulled down like that, just illustrating the movement of that. So it will come here and visit this what? This 9. I think we're going to get 27, and the 2 will be visiting what? Minus 15. That will get us minus 30. Let's write this string profile. Already there we've got 3, I think, minus 3. Is that right? Okay. Is that right? Okay. Then this minus 1 will visit this 3. It gives us what? Plus 3. Then you can see there we get a 0 there. All together. So we're working with a center column here. We're creating a center column there. Is that clear? Okay. Then we come now, it's here. This point here. We're going to get minus 30. And then 20, and then negative 5. Is it negative 5? Okay, negative 5. What do we get there? From these 2, we get 10, minus 10. Then and minus 5, get minus 15. So minus 15. Then we come to visit this one, we get a 6, a minus 10, a positive 4. It's clear to all of us. That is a 0. Then this looks beautiful, eh? Huh? It's promising. Okay. Everybody's happy. Okay. Good. Then we come this one, we do exactly the same thing. We come to two. I'm not going to put it horizontal again. I think people can see now, can see what's going to happen there. We're going to have a 6. No. What am I doing? 27, eh? We're going to have a 27 minus 15, 12. Minus 12. Minus 12. And that's a minus 27 minus 27. That's a 0. Then next, negative 30, 10, 20. And that's a 0. And then 6 is 5, negative 16. This one and this one give us a minus 10, isn't it? And that negative 15. See how beautiful this is. Now we know we left that thing waiting there. Now it's just giving us proof. It's giving us 1, 0, 0, 0, 1, 0, 0, 0, 1 identity. So that matrix is very correct. It's the inverse. Now let's go back right at the beginning. Okay, I was saying let's go right at the beginning. At the beginning, we took our system of equations and put it this way, in matricial form. That is matrix representation of the system. And we said this looks like this, which we said this looks like 2x equals to 8. And we discussed what we're going to do here. All together. Now, we've already checked that when we multiply this A, this is our A. Our A is this matrix. You didn't just write carelessly then say this is A. I'm talking about this is A that is standing there. Now we've seen that when we multiply this A and that, we get an identity. But our task is to solve this system using the matrix inverse. Let me advise you something. If you trust trust your method of calculating inverse, even if maybe some numbers are wrong, you're not going to lose all the marks. There's no need of multiplying this here. What are we going to do? We're just going to simply write now x equals 2. We know what our x is. Then we take our inverse as it is here and write it 1 over minus 1 over 15 brackets 9 minus 15, 3 minus 10, 10, 5, 2 minus 5 minus 4. That. What am I doing here? Before here, what I'm doing? Are we just doing x equals to 2 minus power minus 1 multiplied by 8. So here I'm saying that multiplied by b. So what I'm going to do, I'm going to take this b and put minus 3 minus 5 6. The checking was doing that. The normal checking you do when you are learning. But once you have got the experience, you know how to calculate these differences. Now your task is to solve this equation. There's no need to do that kind of checking to continue waste your lot of time for multiplication. You can just take your inverse and then multiply there. Now here we're just saying x equals to a inverse multiplied by b. So now what we're going to do now, let's multiply this now. Let's multiply this. We're going to get minus 27 there. And what? And 75. 75 and minus 18. What does that give us? 40? 30. Okay, our minus 1 over 15 is sitting down as out there. Then this is that, we close. This is only one column, so we don't need to open a big bracket there. Then we come to the next one. 30. Technically 30 or 30? 30. Yeah. 30. Then negative 50, then 30. So this is what? It's 10.
Yeah.
So you come here is 10. Then next thing, minus 6, 25, negative 24. What is this? It is minus 30 plus 5, minus 5. Minus 5. Then the next thing to do now is to multiply by that 15 then. Minus 1 over 15. I think we're going to get minus 2 and what is this here? 2 over 3 minus, isn't it? And then 1 over 3. Then that is that. We know our x here is x, y, z. Then to give our answer to the solution now to the equation, says that therefore x equals to 2, y equal to negative 2 over 3, and z equals to 1 over 3. Get the values, write them down. You wrote them down, isn't it? So let's go to the first equation. Let's go to the very first. Just check only one equation, which you will check the rest at home yourselves. Let's check only one equation. What is x? Minus 2. Plus 3. What is y? Minus 2 over 3. Plus 3. What is z? Exactly 1 over 3. Okay. This is our left hand side. Do you agree? Okay. No. Let's just work down there. Let's check our left hand side. What it gives us? Minus 2 minus 2 plus 1, and this is equals to minus 4 plus that, which is minus 3. Actually, this is our right hand side. So the equation is solved correctly. Are we together, guys? The process looks a bit long as we're doing it, but once you master it, you will see, you will have your own shortcuts and what. But this is the whole presentation of how to solve an equation, a system of equation using matrices. Okay, thank you for being good listeners.